Okay, well, let's get started on lesson 1.6. We're going to be working with inequalities here. And you can see I already have the first two problems done for you. I just wanted to review this with you, so I went ahead and completed them. In number one, you see those green circles are open on the number line, and that is to indicate that we have a less than sign and not less than or equals to, or a greater than sign and not greater than or equal to. So if there's no equal sign in the inequality, you leave those circles open to indicate that we're not actually including that number. So for example, here we've got x is greater than 0. Remember, you have to think about it. You can either rewrite it so that you can see it better with the x first, or you have to remember that also says 0 is less than x. It's the same thing, but it's easier to reverse the inequality and make it read from x forward, just so you can see it a little bit better. So that's what I've graphed there, starting here at the 0 and then moving over to the right. That would be the x is greater than 0 part. The x is less than 3, okay, that's this portion right here. You don't need to rewrite anything there because they already have the x first. So x is less than 3. That's why I put an open circle here at 3. And then x is less than that. So it's going to go down to the negative side of the number line. And the reason that it is just capped off here between 0 and 3 is because it has to satisfy both of those inequalities. Remember, if you have a double inequality like we do in this number, the line you end up graphing has to satisfy both inequalities, x greater than 0 and x less than 3. Okay, this is an and statement, if you remember that from Algebra 1. If not, that's okay, because over here in number 2, you have an or statement. So x is either less than or equal to -2, which is what you see right here on the left-hand side of the number line, or x is going to be greater than 1, which is this part over here. Okay, so they're not running together. They're going to run opposite directions and away from each other. So remember, an and statement, like in number 1, they're going to run, the inequalities are going to run in opposite directions. One's going to run to the left, one's going to run to the right, but in an and, they're going to come together and meet. In an or statement, they're still running opposite directions, one to the right on the number line, one to the left, but they're not ever going to cross each other. And that's the main difference between those two statements. On -2, I have the dot, the point filled in completely because of this equal sign. So this is less than or equal to, so you have to fill the dot in. On the other side, we don't fill it in because it's just a greater than 1 sign. It doesn't actually include the number 1. Now on number 13, they've asked us to solve the inequality. We're going to do that just as if it were an equal sign, an actual equation, instead of an inequality. So we work them the same way. We're still trying to isolate x. So I'm going to get the term with x in it by itself. Okay, and now I'm going to go through and divide by this -3. This is where things change. If you have to divide through or multiply through by a negative number, once you have done that, you have to switch the inequality to the opposite of whatever it was. So in this case, it was -3x plus 6 is less than or equal to 6. Now, on our final answer, it's going to be x is greater than or equal to 0. Okay, number 16, same idea. Here, though, we have two inequalities. So we've got a double inequality. We can either rewrite them. So let me come over here and rewrite them under number 17 so you can see it. So we've got this inequality, and we also have this inequality right here. This is an and inequality. They're going to run towards each other and meet up. Okay, so we can solve each of them individually, like over here, like this. So you can solve them each individually, or You can solve it all at one time. So here's the middle. I'm coming into that x plus 3. That's in the middle of the two inequalities. They both have that in common. Okay? And so because they have that x plus 3 in common, I can do all of this at the same time. I'm going to isolate the x in the middle by subtracting 3. That will give me, and then I'm going to subtract 3 on both sides of the inequality. So I'm basically just doing that in one step. What I would have to do over here under number 17, what I'd have to do in two separate steps. I'm going to get the same answer. If I did it over here, and you can go ahead and work that out. If you kind of just want to see what that looks like, go ahead and work out these two inequalities on your own. You're going to see you're going to get x is greater than or equal to -1 for the one on the left here, and then you'll get x is less than or equal to 2 on the other side. Okay, so this is your answer. You're done with that one. They didn't ask us to graph these, so we can just move on. Number 18, I'm going to go ahead and do that one because this is an or statement. So we haven't done one like this just yet. We've got two inequalities. I'm going to isolate my x. Okay, and so I end up with x is less than -1 or x is greater than 6. This is an or statement, so they will move in opposite directions away from each other. They will not touch each other on the graph. Okay, now on number 19, I went ahead and did the work for isolating that term, the x, the 1/3 x. So I'm going into that middle part of the inequality. I'm going to add 2 to both sides. Well, to all of it, to the middle and then to the left and the right side. You could split number 19 up into two individual inequalities, just like I showed you up here in this one for number 16. But it's easier just to do it all in one step if you understand and you can keep track of it. At this point now, we need to get x by itself, and that means that we have to divide through by that 1/3. If you remember your rules for dividing by fractions, then you know that an easier way to do it, a shortcut, is instead to multiply by the reciprocal. Okay, so I'm just going to actually change colors here so you can see it a little bit better maybe. So I'm going to come in here to the middle, and I'm going to multiply by 3/1. Just 3 really, but you know, you can put any number over 1. And I'll multiply by 3/1 here and by 3/1 here. So that's going to cancel out the 1/3 in the middle, which is what we wanted. And I'll end up with this as my final answer. Okay, and then on number 20, this requires distributing. So if we need to get that x solved for, then we can distribute first. We could also divide through by that 2. So because the 2 is being multiplied by x plus 3, we could go ahead and divide by 2. And that gets rid of the 2. And we end up with x plus 3 is less than -2. You could do it that way, or you could distribute the 2 to the x, the 2 to the 3, and then go from there. Either way would work. And neither way is better than the other. I'm going to subtract 3 from both sides, and I'll end up with x is greater than -5. All right, in 21 now, they want us to do it all together. So in the front, they split it up. They asked us to graph the inequalities at the top. The bottom, they asked us to solve them. Now they're just asking us to solve and graph them. So it's the same thing you did on the front side. It's just doing it all the way through. So we want to isolate our x's. So I'm going to take all my x's to the right side of the equation. You don't have to do it that way. You could have gone the other way. There's no right or wrong here. Here I'm going to drop down here, and I'm going to subtract 10 from both sides. All right, if I do that, I'll end up with a -8 here and a 4x here. So, and then from there, I'm going to divide by 4. All right, so there was a very real opportunity here for my x to, for that 4x to have been a -4x if I had done the problem a little bit differently. So remember, if you're dividing through by a -4, a negative number at all, you would have to switch the sign of the inequality. switch the order of the inequality. This is written as -2 is greater than x. I'm going to rewrite it as x is less than -2. Okay, they mean the same exact thing. It's just that for graphing purposes, it's a little easier to see it this way. Okay, because I'm graphing it from the perspective of x. So x is less than -2. If this is my 0, I'll write my -2 in here. So x is less than -2, which means I'm open circle on -2. It's not included. And then it's everything to the left of that. On number 22, same deal again as the one on the front. We could distribute the 3 to the x plus 2, but we don't have to because those two are just entities being multiplied together. Then I can divide through by that 3 and skip the distributing step. Either way is right. Just depends on what you prefer. And then I'll end up with x is greater than or equal to 3. So in this case, when I go into graph it, if this is my 0 and this is 2, we'll say this is -2, I'm graphing at x is greater than or equal to 3. So I've got to have a closed circle on my 3 because that equals sign, and then x's are greater than that. Remember, you are graphing what the x's are. So the x value can be 3 or it can be greater than 3, which is why I'm going to the right, because the right values on the number line show greater than. All right, some word problems. In number 23, they give you a time span of 3 years there, where Hawaii's population grew 3.8%. And then they give you two figures, both in the millions. You don't need to know the time frame, okay? That's just extra information. And you don't need to know by how much it grew between 2000 and 2003 to solve this, this word problem, because they just ask you to write an inequality that represents the number of people living in Hawaii during that time period. So if we let X represent the number of people who were living in Hawaii during that time period, well, X, the number of people living there, is either greater than this number, this first number, or I should say actually greater than or equal to, all right? So my X, which is the number of people living there, was greater than this number. That's why I have that inequality sign turned that way. I know it looks like a less than sign, but remember, we're always reading it from the perspective of x. Okay? And then the second number is the max number of people that live there during that time frame. So x is either less than, the number of people living there were either less than this number or equal to that number during that time period. Number 24 asks us to write an inequality that represents the range of points scored by the top 10 all-time leading scorers in NBA history. So you go up to that first sentence, and they give you the score, the number of points that the top scorer in the NBA has scored. You go to the second sentence, and they give you the 10th player on the list and his score. They skip numbers 2 through 9. You don't need to know the scores of players 2 through 9 because they've given you the top most and they've given you the bottom most number of points on this list, and they just want the range. So if we let x equal the range of points, then we know x is either less than or equal to this top most number right here, or x is going to be greater than or equal to this bottom most number. Okay, and then on number 25, they ask us to write an inequality that represents the various distances that we could travel on this German Autobahn where there are no speed limits. So what are the various distances we could travel for if we traveled 2.5 hours and the maximum speed we went was 135 miles per hour? All right, they want an inequality. If we figure out, first of all, how far we could travel if we travel 135 miles per hour for 2.5 hours. Let's say we never let off the gas, and 2.5 hours we travel at that exact same speed, you multiply those together and you're going to get 337.5 miles traveled. So that is the absolute maximum that we could cover, the max distance. If we let x equal the various distances that we could travel, we're going to say x is the various distances, then we know, based on this multiplication problem we just did, x has to be less than or equal to that distance. So it's going to be somewhere in that range. We're definitely not going over it, but we could go anywhere underneath of it depending on how fast we travel for that 2.5 hours.